Let's go start to finish on the process of creating a line representing the stream and creating a terrain profile from this line on the stream we visited with a workshop on Wednesday. I already have my elevation model, but we can go to the NOAA Data Access Viewer, Elevation, LiDAR, zoom into our area of interest, and around wherever that area is, we can draw a search area. Click, hold, drag, release. Go to our shopping cart and then proceed to download our data. We will go with the defaults on this grid method average, all other defaults kept unless you want to do something different. Now we have our 1 meter resolution digital elevation model, but we want to see that as a multi-directional hillshade. So under imagery, we will go to raster functions, scroll down to surface, hillshade, click hillshade, make sure we're selecting the right elevation model, hillshade type, multi-directional, I like a Z factor of 2, and create new layer. Now we can see where we were with the workshop here. There's a little tributary just downstream coming in from the west. There's our culverts, and if we scroll out we can see we've got several other road crossings here. So I'm actually going to draw this line from up here all the way down as far as we can go here. So I'll create a new layer under View, Catalog Pane, and then we'll scroll down to our working folder, say New, Shapefile. We want a polyline. We'll call that Demo 1, and use the coordinate system of the current map, NAD 83, UTM Zone 19 North. Now I like a nice bright yellow for my lines here when I'm working, so I'm going to change that to yellow and 2 points across, apply. Now head over to Edit and Create. Select our Demo 1, and let's see, where do we want to start? Let's go ahead right up here. So I can see my stream channel fairly well on this multi-directional hillshade. I'm going to follow that as best I can, and we will check in on the other side. And at this point I'm feeling like we've got about far enough, so I'm going to wrap that up. We have our original site here, we've come down there, and started above these other crossings here. Now I'm going to make sure to save my edits, and then we're going to get into an issue that I have with ArcGIS Pro, which is when I search for terrain profile, I do have the profile tool, but it's not like it was in ArcGIS Desktop, where it would read directly off an elevation model that you gave it. What you have here is a elevation model that comes off the server. We're going to ask for the finest. I think we'll get 3 meter resolution here, and run. Now we have our output profile, which is in our line here. Right click and create chart, profile graph. And this is the terrain profile off of the, let's see if I was right about that, the 3 ArcSec product, whatever that is exactly. So now I've brought this over to QGIS, which has the functionality that I want. So if I go to install plugins, manage and install, under the all window here I can search for profile tool. I already have this installed, but if I didn't, I would want to select that and install the plugin. I already have it, so that means I have this icon here for terrain profile. I want to make sure I've added in my DEM so I can read straight off the highest resolution elevation model I have, or any other surface. Now I'm going to select my Demo 1 and use the selection selected layer. Now I can drag my mouse over here and see that bump there is that stream crossing, that bump there is another stream crossing. That bump there is the stream crossing that we are interested in, so I can zoom in here and I can see what's going on with that road there. So we can make this graph bigger by changing the size of this profile tool window, and we can see road crossings 1, 2, and 3 with a big drop off after number 2. This quick look at the broader context of stream crossing might be one of the more useful parts of this exercise if we can decide where best to start and stop our actual survey on the ground. Do we want to start here? Do we want to start here? And so on. But zooming in with the scroll wheel, we can get a closer look. So here we have it about 1,200 meters, 100, 200, 300 meters that way, 100, 200, 300 meters that way. If we go ahead and save as, we can call that demo 1, save. Being just ridiculously low tech here, we can drag that into Microsoft Word where we can draw a line from our 300 meters upstream to 300 meters downstream, and maybe see some of the effects we were talking about where material might be deposited when water is backed up here, and then maybe scouring out below, depositing below that effect, and so on. And here's another one that I did earlier. This is the road here. We have a flatter section just above it, and this is how that one looks in the lower resolution ArcGIS elevation model. So back to QGIS, we see we have our inflection point at the 1,000 meter interval here. There's our road at 1,200 meters. So that is where we would go if we wanted to see where that inflection point was, right about here. So I wouldn't really expect this to take the place of a field survey when we're actually designing a project, but if we are allocating limited resources among 10 sites, we could probably afford to do this for each one and see which one has the greatest need, or maybe one more office step to say we'll start our survey here and end it here, or go all the way out to here, or survey all the way up to this spot here and find out what's going on with this.